Okay, so good day everyone. So this is another discussion, or recorded discussion from me to you. So our topic for today is shear stress and bearing stress. So dito i-discuss natin yung iba't ibang uri ng shear stress maliban dun sa na i-discuss ko nung last discussion natin. So examples of direct shear. So una, si single shear in a rivet. So, makikita nyo yon yung single shear dito kay figure A. And yung pangalawa, si letter B, double shear in a bolt. So, so obviously, in figure B. And yung pangatlo, and last, is si shear in a metal shear produced by a punch. So, yung pangatlo na yan actually is also called as, or also known as the punching shear. So, by definition, si normal stress acts on an interior plane and is directed perpendicular to that plane. So, normal. So, paulit-ulit na lang sinasabi. Perpendicular, Normal is perpendicular. And si shear stress, on the other hand, is tangent to the plane on which it acts. So, kapag tangent, dumampi, Or, it can be considered as adjacent to the plane. So, kung si normal stress ay parallel, si shear stress naman ay tangent or adjacent dun sa plane kung saan siya nag-a-act. Si shear stress arises whenever the applied loads cause one section of a body to slide, to slide past its adjacent section. So, kagaya nga ng sinabi ko, shear stress is tangent or adjacent to the plane kung saan siya nag-a-act or kung saan cross-section siya nag-a-act. So, meron daw 3 examples of shear stresses. So, yun nga, si single shear, si double shear, and si punching shear. So, kay figure A, ito na, discuss na natin kung ano yung tatlo na yun. So, sa figure A daw, it shows 2 plates that are joined by a rivet. So, para sa kaalaman ng lahat, si rivet ay kagaya or katulad ng isang bolt. So, rivet or rivets are used as connectors. So, limbawa daw, meron daw tayong dalawang plates dito. So, ito yung plate number 1 and yung plate number 2 yung nasa ilalim. And nasaan si rivet? Obviously, itong bilog na to. Tapos, kung titignan nyo, anong tinignan yung side view na itong plate 1 and plate 2? Makikita ninyo merong imaginary lines dito sa gitna. Yan yung katawan ni rivet. And given in this figure is external load P, applied on both sides, or on both plates, perpendicular to this cross section, So normal force perpendicular to this cross section. So ngayon, kapag daw nag-exceed yung force P na yan sa capacity or sa allowable stress, nitong plate or ni rivet, ano daw mangyayari kay rivet? So as shown in the free body diagram, the rivet must carry the shear force V, equals to P. So itong P na to, magkokos siya ng shear force letter V, as denoted. So yun. So kapag shear ang pinag-uusapan, tandaan, ang symbol for shear force is a capital letter V. So the rivet is said to be in a single shear because only one cross-section of the rivet resists the shear. So ano daw ibig sabihin nun? So mapuputol siya dito sa gitna. Saan ba niya pinagdudugtong yung dalawang plate? Obviously dito sa gitna. Kung hindi nakukuha, tignan mabuti yung plate. Di ba pareha sila ng thickness in this situation? Tapos equal yung thickness na kinukuha or na-occupy nila ng body nung rivet. So kung halimbawa, equal din tong dalawang force P na yun, tapos nag-exceed sila dun sa actual capacity nito at puputulin nila or ang talagang gagawin nila is putulin tong si rivet, magbe-break yan dito sa gitna. So that is why it is called a single shear. Dito, pinakita sa free body diagram, nung kinuha siya by method of section. So, inassume na dito siya magbe-break sa gitna. No? Or not just assumption, simply by analytical investigation lang. Maipapakita mo naman na talagang mag-fail or magbe-break siya dito sa gitna. So, ayun, V equals to P when you construct a free body diagram. So, next is yung figure B, yung double shear in a bolt. So, sa figure B, so the bolt of the clevis in figure B, as repeated, carries the load P across to cross-sectional area. So, nasaan daw yun? Meron ka daw dalawang cross-sectional area. So, si area 1 and si area 2. Ayun yun, yung ginuhitan ko. Sige. Himay-himayin natin. So, the shear force being V equals P over 2. Bakit? Kasi, dalawa yung i-consider mo na cross-sectional area. Ayun, pinakita sa free body diagram. Ibig sabihin lang ng P over 2 na to, yung applied force P mo is mahati sa dalawa. Okay. Having the bolts to be in a state of a double shear. Let's say for example, itong clevis na to, So, dalawa yung kino-consider mong body dito. And you connected them using a bolt. So, kapag itong force P na to, is nag-exceed dito sa may capacity nitong dalawang body mo or ng bolt, I must say, ang mangyayari is magkakaroon ka ng double shear, na makikita mo through this cross section or to this sides of the bolt. Unlike the figure on the first part, or in figure A. They are only connected on one side. Okay, so here's the free body diagram for double shear. Sa pangatlo, a punching shear. So in figure C, a circular slug is being punched out of a metal sheet. So circular slug being punched out of a metal sheet. So from the term itself, or dun sa phrase pa lang na yun, pwede na kayong makapagbigay ng conclusion kung ano si punching shear. Actually, pwede kayong makakita nito in your household and in your school or in our offices. So, ano example ni punching shear? So, si punching shear, ang isang example niya is a puncher actually. So, di ba kapag halimbawa nagbubutas kayo ng papel o kaya manitipis na cardboard, makikita nyo, pag isinangat nyo si punching shear dun sa may bilog or dun sa may circular slug, sa may pinakangipin ng puncher, bubutas siya dun sa may papel or dun sa cardboard. And it's like, or it's actually the concept of punching shear. So here, the shear force is P. So, ayun pa rin, Si P pa rin ang kino-consider nating shear force. And yung shear area is similar to the milled edge of a coin. So, ano yung shear area? Ito yung area A or yung cross-sectional area A na i-consider mo or i-analyze mo before using our formula stress equals to P over A. So, ito daw shear area na to ay kagaya daw ng edge of a coin. So, ano ba yung edge of a coin? So, kung gusto mo malaman, kuha ka ng barya. So, tignan mo yung gilid ng barya. Pagkayari nun, tawag dito. Ikumpara mo yun sa, binutas mo sa puncher. Okay? Yung pinakagilid na yun, yung pinaka-edge hindi yung pinaka-top and bottom or yung other sides of the coin. Yung pinakagilid, yun yung sosolvin mong area for shear area. And ano yung mga values or variables na kailangan mong i-consider doon to solve for its area? Actually, the thickness T and the circumference of the coin. Let's say, for example, ito yung gilid ng coin mo, no? Ayan. Ayan, ang pangit na naman. Ulit. Yan, halimbawa, ganyan na lang. Huwag na nating gandahan. Kinuha mo daw gilid ng coin mo. Sige, ganito. Yung coin mo, hatiin mo sa gitna. Pagkayari mo hinati sa gitna yon, exaggeration ano, unatin mo daw siya. Then makakakita ka dyan ng parang rectangle na manipis. So, how do you solve for the length of that rectangle? Obviously, kapag inunat mo or binalik mo sa dati yan, yung bilog na ganyan, ano? Yung bilog na ganyan. Pag binalik mo sa dati yan, the length of the rectangle na makukuha mo is yung circumference C nitong coin. And then, to solve for the area, finally, of this milled edge, na consider mo as shear area, the circumference C must be or would be or kailangan nating i-multiply kay thickness letter T. Kung ano yung binigay na value ng thickness T. So ano ba ang circumference or ang formula ng circumference ng circle? Obviously is just 2 pi r. Then 2 pi r T. So ayan yung gagamitin mong formula para ma-solve yung area ng milled edge of a coin daw na tinatawag, no? When comparing or visualizing in your brains or in your minds kung ano yung gagamitin nating shear area para kay punching shear. Ito, pinakita naman siya sa free body diagram actually. So, nasaan dito yung thickness T? Obviously, ito, no? Yan, yung kapal niya na yan. Yan yung thickness T. And kapag binutas mo daw siya, ito yung pambutas mo, yung force P mo, kapag lumubog yan dun sa may bubutasin mo, syempre, yung nakaikot dyan, ano, with respect or in line with the thickness T, kung saan mo siya binaon, yun, ano, yung paikot na yun na bilog, yun yung circumference, ano, yun yung kukuhanin mong multiplier para dun kay thickness T to solve for the area. Okay? So moving on, the loads shown in the three figures are sometimes referred to as direct shear. Ayan, tatandaan na. Naka-highlight na yung mga terminologies and definitions na dapat nyong tandaan in mechanics of materials. And the distribution of direct shear stress is usually complex and is not easily determined. It is being common to practice to assume that the shear force V is uniformly distributed over the shear area A. So that the shear stress can be computed from ito. So given by the symbol tau, no? The symbol tau means shear stress. Shear stress is equal to shearing force V over the shear area A. So, yun ano. So, it is only derived also from the formula P over A or stress or force over area. So, strictly speaking, shear stress tau equal to shearing force V over A is interpreted as the average shear stress. And it is often used in design to evaluate the strength of connectors, ayun ano, such as rivets, bolts, and welds. Okay. So, bakit ginagamit tong average shear stress in designing or evaluating the strength of connectors such as rivets, bolts, and welds? So, malalaman natin dito kay next part, bearing stress. Okay. So if two bodies are pressed against each other, compressive forces are developed on the area of contact called bearing stress. So ano daw ba ibig sabihin nito? Two bodies are pressed against each other. So halimbawa, dito sa figure natin. Okay. Sa figure A, ito tingnan. Kagaya nung figure A dun sa topic sa shearing stress sa taas. Two bodies pressed against each other. So consider the top section of these two plates, ano? So nasaan yung top section na yon? So ito, no? Ito, yan, yung taas na yan. Yan, yung top section. O sige, yung top section lang ang tignan, alisin tong lower section. So ano daw ba yung sinasabing two bodies na yon pressed against each other? Consider this plate as body number 1. And yung body ng bolt as body number 2. So, yung dalawa daw na yan, kapag itong force P ay nag-act dito kay plate, hinila siya, no? Or nag-apply ng tensile force dyan, or compressive force, either way, tatama daw yan sa katawan nitong bolt or rivet. At ang nangyayari, yung compressive forces daw ay nade-develop dun sa area of contact. Saan ba sila nagkakaroon ng contact? Saan sila nagbabanggaan? So, obviously, dito sa katawan ng bolt, and dun sa may butas nitong plate. Yan. So, yan yung tinatawag nating two bodies pressed against each other. Tapos, yung resulta nila is what we call the bearing stress. So, ano nga ba yan? So, examples of the bearing stress are the, unang-una, soil pressure beneath a pier, and the contact pressure between a rivet and the side of its hole. Ayun nga, yung diniscuss ko dito sa figure A. O sa example yon, between a rivet and the side of its hole. So, if the bearing stress is large enough, kung malaki daw masyado yung bearing stress, it can locally crush the material that could lead to more serious problems. So, halimbawa, itong plate na to is a gusset plate or yung connector or yung material na nagko-connect sa members of a truss. Tapos, ngayon, hindi siya properly designed. Ngayon, lumaki yung bearing stress. So, ano nga ba yung ibig sabihin ng lumaki yung bearing stress? Saan siya mag-re-result? So, ngayon, yung pinagkakabitan mo daw nitong bolt na to, kapag umover yung bearing stress, ang nangyayari, lumuluwang itong butas. Okay? Lumuluwang daw yan. Kung hindi mag-fail yung plate, ang mag-fail daw is itong bolt. So, you must consider also the bearing stress when designing such structures. Hindi basta tira lang ng tira. Okay? So, kung hindi mapupunit yung plate, ang masisira is yung connectors or yung bolts, for example. And that is one serious of a problem. So, to produce the bearing stress or to produce bearing stresses, engineers sometimes employ bearing plates. So, ayun. Gusset plate is one example. So, ano daw ba purpose nun? Ang purpose daw nun is to distribute contact forces over a large area para magkaroon ng balanse or equal distribution ng contact forces over large area. So, hindi lang siya nakafocus or nakakonsentrate sa iisang lugar. Ikakalat niya over a large area para hindi magkaroon ng failure or ng mga problema. So, ito naka-note. Example of bearing stress. So, letter A is a rivet in a lap joint. So, ito nga yun sa figure A. Yung pangalawa, bearing stress is not constant. So, ayun, hindi daw siya pantay. So, siguro, kaya hindi siya pantay, ang nangyayari, in-applyan ng force P dito, which is a compression. Makikita nyo, di ba, mas maluwang daw yung side na ito kumpara dito sa side na to. Ibig sabihin lang, kung titingnan mo or by the use of your common sense, sentido común, yung force P is patulak dito sa may side na ito. Kaya siya nagkaroon ng pagluwang dito sa may side na to. And for the final figure, figure C, bearing stress caused by the bearing force P sub D. So, it is assumed to be uniform on projected area TD. So, ano ba yung TD na yun? Yung TD na yun is yung area na consider mo when you are solving for the bearing stress. So, that T represents the thickness of that plate, o plate in the given example. So, and D is yung lapad, yung lapad nung hole or in diameter of the hole. Okay? Kasi kung makikita nyo, si bearing stress, kagaya dito kay figure B, kung saan siya nag-a-act, yun yung kukunin mong cross-sectional area. So, for example, dito kay figure B, di ba ito yung kukunin mong area. So, kagaya lang din yan, or halos kagaya lang din yan nung kay punching shear. So, kung di ba dito siya tumama, dito siya pumasok, dito siya nagka-epekto. Yan, dito siya nagkaroon ng problema. So, ibig sabihin, itong side na ito yung nai-stress. Yan. So, yan yung i-consider mo as bearing area. Siya yung nagdadala nung bigat. Okay. So, as an illustration of bearing stress, consider the lap joint, itong lap joint daw from figure A. Yan. Lap joint formed by the two plates that are riveted together as shown. Ito yun. Being the bearing stress caused by the rivet is not constant. So, hindi palaging, may isang value lang. Actually, nagva-vary yan from 0 to the sides of the hole to a maximum behind the rivet as illustrated in figure V. Ayun nga, kagaya nga ng sabi ko dito, kung saan yan pumasok, halimbawa, permis na nakakompress itong side na to, o permis na lang din siya na itutulak dito, ganun na nangyayari. Nagkakaroon siya ng abnormality dito or nai-stress to, na-overstress yan. Nade-deform siya. So, kung halimbawa naman, yung design mo ng hole, or yung design mo ng bolt is unproportional. So, bakit ko sinabing unproportional? Halimbawa, hindi siya sukat dito. Actually, kasi pag nagde-design ka ng plates or ng bolts, ng bearing plates, kino-consider mo rin yung bolt diameter and diameter of the hole. Meron tayong tinatawag na staggered connections, meron din tayong tinatawag na yung standard connections. So, hindi ang pagkakaalam ko, hindi masyadong maluwang, hindi rin masyadong mahigpit, yung tama lang para hindi siya over-stressed. So, kung dinedesign dyan, kung paano i-design yan, you'll know when you proceed to such higher engineering courses like steel design. So, dito, yung concepts lang ang pinag-aaralan natin. Okay? So, ayun. The difficulty inherent in such complicated stress distribution is avoided by the common practice of assuming that the bearing stress is uniformly distributed over a reduced area. So, ayun na nga yung sinasabi ko, So, kung saan tumama or saan pumasok yung bearing force P, okay, yung kabaliktarang side niya, or yung opposite side niya, yun yung mag-re-react. Halimbawa, kinokompress mo nga itong side na to. O, ano ba itutulak niya? Di ba itutulak niya mismo yung plate? O, pag tinulak niya yung plate, ano nangyayari? Naaalog yung bolt. O, naaalog yung bolt dito sa loob. Tapos, ang nangyayari, yung side daw ng bolt, kung saan tinamaan ito, tutulak niya papunta dito. So, yung side dito, ang nangyayari, nagkakaroon ng contact dito sa side ng plate na to or dito sa inner cross-section ng plate na to, ng butas ng plate na to. So, pag nagkakatamaan yan constantly, ano nangyayari? Lumuluwang yung butas. So, itong sinasabing reduced area na to is yung area dito. So, hindi naman siya buong-buong nagdadala ng bearing stress. Hindi yung buong paikot na to is nagdadala ng bearing stress. Kung saan lang nakatutok yung direksyon nung forces applied. So kung halimbawa nandito siya sa kabila, dito mo in-apply yan. Or kahit i-tension mo pa to. Kahit i-tense mo man to. Halimbawa yan, i-tension mo to. Yan. O. Paano ba siya magbe-bearing? O di ba? Magkakaroon din ng contact on either side kung pwede rito or pwede rito. So you need strong analysis pagdating sa mga gantong cases. Okay. So the reduced area, capital A sub B, is taken to be the projected area of the rivet. So ano yung projected area ng rivet na yun? It is actually given by the free body diagram from figure C. Ito, T, which is the thickness, times D, which is the diameter. Okay? TD. Yun. In which magka-come up tayo dito, sa formula natin nga na to. Sabi ko na nga, A sub B is equal TD. Ayun. Diameter of the rivet yung D, and yung T is thickness of the plate. So as shown in the free body diagram of the upper plate in figure C, okay, from this free body diagram daw, or from that free body diagram, the bearing force P sub B, ayan mali pa ng guhit, sa taas pa na ilagay, pero okay lang, equals the applied load P. Ayun. Ulitin ko, the bearing force P sub B equals to the applied load P. Or, the bearing load will be reduced if there is friction between the plates. So, yung bearing load daw ay babawasan mo or mare-reduce kapag merong friction na nag-a-act between the plates. So that the bearing stress becomes, magka-come up na tayo sa formula. Kagaya nga ng sabi ko, karamihan sa mga formula sa mechanics of materials or stress, formulas ng stresses kay mechanics of materials, ay galing kay stress equals the force P over the cross-sectional area A. So, dito sa bearing stress, sa formula ng bearing stress, we have P sub B over A sub B. So, yung P sub B na yun is the bearing force, yun. And it is equal to force P. Nasaan yung force P na yun? So, from these figures, makikita mo, eto si force P. Yung external load na in-apply mo dito sa body. Or in our scenario, the plate, na magta-transfer dun sa bolt and magpo-produce ng bearing stress kay plate. Yun si force P. And force P is or will be divided by our bearing area or the reduced area for our bearing area equal to the thickness of the plate T multiplied by the diameter of the rivet D. Yan. P over TD. So that concludes it, the shear stress and bearing stress. So you'll have to wait for the sample problems. Thank you, and that's it.